In this step, we'll create the projectile that will be fired at the asteroids using gaze input. Start by creating a sphere game object. Let's rename the sphere. Let's first move it out to this in front of our camera and rename it as a projectile. And let's also go ahead and change the scale of the x, y, and z to 0.5, 0.5, 0.5. And once we've done that, we're just going to create a material. So let's go ahead and go to our materials folder, right click, create material, and let's go ahead and name it projectile as well. Change the rendering mode to transparent and the albedo color to red. So once we've done that and picked a good red, we're going to change the alpha channel as well. And we're going to match that color for the emission and darken it just a tad to get the effect that we want. And then after we've done that, let's go ahead and drag that projectile material onto the projectile, and we can see it applied there. So that looks all good. Now, if we go to... So our next step is going to be to create a new script. So let's go ahead and move to our scripts folder. Let's right-click, create, C# script. And let's call this one projectile as well, just keeping with the nomenclature we've established. Double-click it, let's open up MonoDevelop, and let's take a look. So for this script, what we want to be able to do is we want to actually move the projectile every update. So we're going to start with transform.position plus equals transform.forward times time delta time times another scalar. And this is a common way of moving an object in Unity. Basically, what we're saying is we want to move it along the forward vector, which is 0, 0, 1, by time delta time, which is the normalized time across each frame, and multiplying that by a scalar just to give it a little bit of time. So let's add that line in. Let's also go back to that other script, copy and paste these transforms in, because we're going to be using the same set of values here. And the last thing we want to be able to add is a time deletion. And the way we're going to do that is we're going to use a coroutine, which we're defining here, destroy self. So what we're going to do is we're just going to say yield return wait for seconds 2.5f, and what that's going to do is it's going to run this function if we call it, and if we call it, it's actually going to destroy the game object after waiting for 2.5 seconds on a separate thread. So that's obviously going to be pretty useful because we don't want our projectiles to be flying around for longer than that. Otherwise, they'll clog up our memory, and it might slow down the performance of our game. So our next step is going to be to actually make a prefab out of our projectile. And once we've done that, let's go ahead and save out just to make sure that we don't lose any work. And let's go back to our script. And if we go to our player script, actually, we can see that we can look at this. We're actually going to add a couple lines here. So the first thing we're going to do is we're going to add a reference to the projectile that we just created, that the prefab basically is what we're going to want to drag in as the reference. And then the next thing we're going to want to do is we're going to want to add a method for shooting. So all we're really going to do inside of this method is we basically want to get a array from, we need to know where the head is positioned, and based off that, we're going to shoot a ray out from the head, and that's going to tell us the vector that we want to instantiate the projectile that we're going to fire. The projectile being the projectile prefab, which we just defined up there. So this is pretty standard code. We're not doing anything too crazy here. We're just using the head transform values, and we're normalizing them. And as you might recall, normalizing just means a vector of length 1, similar to a unit vector, but with an actual direction. So that allows us to make sure that length is not a factor in our calculation on where the actual projectile should be fired. And so the last thing we need to do is to just instantiate, okay, we're going to instantiate the projectile, we're going to use ray.getPoint6 and quaternion.lookRotation forward. So once we have that, let's go back to our project. Let's go to our projectile. And so we're going to add a tag here just to make it simple for the collisions. with the projectile. So let's go ahead and add the projectile tag. Let's click back on the projectile and make sure we actually tag it with projectile. So once we've actually tagged it with projectile, let's save that just to make sure. And then let's go back to our model develop and let's go to asteroids.cs. So we want to implement IGVR gaze responder in this script as well. So obviously once we've included that as an interface, we're going to have to put in the requisite methods. So I've already copied them, and let's paste them in here. And so IGVR gaze responder gives us access to on-gaze enter, on-gaze exit, and on-gaze trigger. So first let's also add a reference to the player, and let's also take the player and make him equal to, we're going to do a game object.find on GVR main, and then get the component of the player script, just so we have access to him and we can use that in our on-gaze trigger. So if you remember in the other script how we had that shoot function which spawned the projectile, so we're actually going to call that when we trigger on our gaze with player.shoot here. And if we go back to our player script, let's copy and paste that on collision enter back into our asteroid.cs so that we know, and let's change that to, instead of asteroid, let's change that to projectile, so that if a projectile hits the asteroid, we're actually going to destroy the asteroid itself. And this would be where you might want to add some sort of scoring mechanism or some way to let the player know that they've done something good. But for now, we'll just leave it as such. And yes, we do still want to destroy the projectile as well, because we don't want them to destroy more than one asteroid at a time. So the last thing we're going to do is we're going to go to our player script, drag the projectile in as the reference. Let's go back to our asteroid, and we're going to need to add an event trigger, sorry. Let's add a new event type, pointer enter, pointer exit, and also pointer click. So once we've added those pluses, make sure you drag in the asteroid script to these boxes. And what this does is basically anytime these events fire, we want to run the on-gaze enter, the on-gaze exit, and the on-gaze trigger. So these are the event systems that are going to fire off the scripts that we just wrote. So let's go back to our projectile, add the projectile script as the last thing, and let's test this out and see where we are. So you can see if we hit an asteroid, you can see both the projectile and the asteroid themselves both get destroyed, which is good. That's exactly what we wanted. And yeah, so we actually, we're doing pretty well here. So our next step is actually going to be to add in a game over, basically a game over scenario. But before we do that, actually, let's go back to our asteroids.cs script and let's add in an on-collision enter. Let's say if the transform.localscale.x is less than 18, then what we want to do is we want to create a new asteroid. So basically the idea here is that if it's a big asteroid, let's have it spawn smaller asteroids. And if it's a smaller asteroid, we'll just leave it alone. So this is more similar to kind of how the original Asteroids game is played. That's why we decided to include this. So it's pretty simple. We're just going to be doing an instantiate right here on the actual, and we're using GameObject to refer to the actual asteroid itself to create another version of itself, basically. And the reason that we actually, in this case, want to cast to the type GameObject, so previously we would have just said instantiate GameObject vector3 plus the quaternion rotation, but this time we're actually casting to the GameObject and saving it as asteroid. And the reason we're going to do that is because we want to change an attribute of it after we spawn it, and the attribute that we're going to change is actually going to be its local scale. So if we created the same GameObject as the one we had just destroyed, then this game wouldn't really make sense, because you would shoot an asteroid, a big one, and it would spawn another big one. So rather than doing that, what you're going to see here in a moment is we're actually going to change the scale to 12 instead of 18, which is going to make the asteroid actually a lot smaller, and that's a noticeable difference from the player's perspective, which is exactly what we want. So this is going to be our last line right here. So you can see we did asteroid.transform.localscale, and we're actually going to do a minus equals new vector 3, 12, 12, 12. So that's actually going to put the scale at 6 because we're subtracting 12 from both the x, y, and z axis there. So let's save that out. Let's hit play. And now, anytime we hit a big asteroid, you should see a smaller asteroid pop out. And once you hit the smaller asteroid, it should be deleted on its own. So you have it. So in our next video, we'll be talking about the game over and everything else. Thank you for watching.